What's up, everybody? This is Mr. O'Brien. We're going to be talking about part two for quantifying matter. This information will be on section 11.1 in your textbook. The idea here is to understand how we count objects in chemistry and what is that amount of objects that we count when we see. So let's start off with this picture here. So you have this little girl here who's counting up coins, and she can clearly see the amount of coins that she counts up, right? Um, Now, we always seem to have to rely on sight to count objects, but are there other ways to count objects? So consider the following, man. We in this class have to count objects by measuring the mass of the objects. So think of this example. So this roll of coins has a mass of 125 grams. If the mass of a penny is 2.5 grams, how many pennies are there in this roll? Pause the video for a second and then play it when you find out the answer. So we can't see these pennies, right? But if we know that there are, if each penny is about 2.5 grams, then what we can do is we can divide the mass of the total sample, right, by 2.5. And what we end up finding out is that there is 50 pennies, right? And it's crazy because, yeah, sure, it's 50 pennies, but you can't see the 50 pennies, but yet you know the 50 pennies are there. See, that's the type of counting that we do here in chemistry. So the question is, why do we count objects in chemistry by mass? Because the objects that we want to count are too small to see, right? And so we've kind of talked about this idea of how small these particles are. Like consider, for instance, like the electron, right? The electron, like, take a look at the gram value, right? The electrons are essentially like this small. If I were to write all this number out, it'd be like 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So there's a 28 spot. Now, that's tiny, but that's grams. And so you guys had an experience in our class about using grams on a scale. And our scales typically, if it measures anything, can probably go to a hundredths, right? Man, we can't even see this number, right? We can't see this number. So, I mean, that's how tiny these particles are that we're looking at. So the mass also can give you an indication of what the amount of particles it is that we're trying to count. So, for instance, if I let me erase this out real quickly here. If I show you, right? If I show you, oh, sorry, I'm skipping ahead. If I show you the mass of an AMU, you're like, oh yeah, one proton is one AMU. Oh yeah, one neutron is one AMU. They're the same, right? But the mass in grams, which is ridiculous to identify in grams because it's extremely tiny, right? But yet we use grams to the measurement of units in grams when we use things on the scale, when we try to see things on the scale. So whenever you see the unit grams or kilograms or obviously pounds or even tons, you know that you have a whole bunch of stuff, right? When we talk about AMUs, we don't have any instruments that measure AMUs, right? So these are talking about just a couple of things, maybe even some atomic particles or even like one or two atoms or even maybe a group of atoms. We're really focused on this unit called grams, and we're not going to measure something this small in this class. We're going to be measuring, a lot larger values, right? But the idea is that it measures a lot of atoms. Okay, so let's continue on with this topic. So I showed a video in the class that talks about a mole. Okay, so for the sake of this lecture, let's describe what a mole is. So a mole represents this much stuff, 6.02 times 10 to the 23rd stuff. Now I call it stuff because it depends on what you want to call a mole. Like you're still kind of confused probably, like, what do you mean, what is a mole? Well, think of like a dozen, right? If you have one dozen, right, you know that you have like 12 stuff, right? A dozen roses, you're gonna get 12 roses, right? A dozen balloons, you're gonna get 12 balloons, right? But the dozen in this class, right? To use a dozen in this class is also as ridiculous to use a gram to measure, like, say, one proton, because the amount of stuff that we see in grams is huge because the atoms are tiny, are very tiny, extremely tiny. How tiny? Well, so tiny the fact that we need to use a new type of dozen called the mole. And that mole represents that much stuff. 1 mole is that much stuff. Now you're like, well, what is the mole? Like, what does this number even look like? Dude, this number here is the following on top: 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So we're talking about 100,000, million, billion, trillion, quadrillion, quintillion, finally 602 sextillion. That's how much stuff is in a mole, right? One last thing. If you had a mole of softballs, roughly the mole of softballs will be, in terms of volume or size, they would be the same as Earth, right? So a mole is huge. Let's continue on. So how many atoms are we actually looking at when we're looking at stuff at a macro scale, right, in grams? Well, we're looking at some degree of a mole, right? I'm saying a degree because we don't know if it's a mole or, we're just talking about a mole, right? So some degree to a mole. And a mole is equal to this much stuff, which we just showed you, or I just showed you, is equal to that much stuff, right? So we want to measure a mole, right? And anytime we use grams, we're talking about some degree of a mole, right? Now, the next question, right, that we're going to hit up is, well, how do we know how much stuff is in a sample? So how do we know that in this case here that we have exactly this many amount of atoms if you see 12 grams? Well, that's a great question because what we need to understand is we need to understand something called the molar mass. So you're starting to learn a little bit more about the periodic table. Here's a 1 square from the periodic table. So this square from the periodic table shows you an element carbon with 6 protons, the element's name, and then some number on the bottom, which in some periodic tables tells you it's an atomic mass. But for the sake of this class and right now, it is called a molar mass. And why is it called a molar mass? Because on the periodic table, every number that's below the symbol tells you in grams, right, that it will show you that much grams on a scale when you have this many atoms. Hence, that's why it's called the molar mass, right? So when I look on the scale here on the scale, I see 12 grams, and I know it's carbon. Let's pretend that I know it's carbon. So if I know it's carbon, it says 12 grams. When I look on the periodic table, hey, the periodic table shows the same number. Hey, that must mean it must be a mole of stuff, a mole of things. And what things are we talking about? Well, we're talking about atoms. And so because this number is the same as the periodic table's number, we know that right here, it will have this many atoms. Hence, molar mass. Okay, let's continue on. Right? Let's practice this example together. So how many atoms are present in this following sample of sulfur? Right? So here's sulfur. Here's the scale that sulfur is on. Notice that there's no, tray or no filter paper or anything of that sort. You see 32 grams, right? Well, how much is there? Well, the first thing I want to do is I want to find the molar mass of sulfur. I want to look on the periodic table, and I find this. I find 16 protons, S, and then the number here says 32.066. When I see this number, this 32.1, and I see this number, it is telling me that I have a mole. And you're like, wait a minute, it's got a sort of 32.0. But sure, let's round it up. Let's round it up to 32.1, right? Well, it's got a mole of stuff. And so because it's weighing 32.1 grams, it must mean that there are about 6.02 times 10 to the 23rd amount of atoms. Okay, there are about 1 mole of atoms. Okay. Now you're like, wait, that many atoms, 602 sextillion atoms on that scale? Yeah, that's how small atoms are. So let's move on. So what I want you to do now is I want you to take a look at this question here. So this question shows you 4 samples, right? And they have the masses here. And I want you to answer these 3 questions based on this picture that you see here. If you have any questions on how to answer, if you have a hard time, hit me up a tutorial and then we can work together on these. So let me give you another kind of a variation about that question. So in this question, I want you to predict the mass and the amount of atoms the scale would show if you had half a mole of atoms of carbon present. So now I'm telling you have a half a mole of atoms. Now I'm telling you that this right here is, I'm telling you have 0.5 moles. The question is, what will this show you? So let's pretend that we already accounted for the mass of that sack or whatever. Let's figure out what we need to do now. Well, because it's carbon, again, I should look on the periodic table and take a look at what the molar mass of carbon is. It's 12.011 grams. Now, if 1 mole is 6.02 times 10 to the 23rd atoms, right, which equals 12 grams, because this is called a molar mass, right, the 12 grams of molar mass, right, I don't have 12 grams because I actually have a half a mole. So then if 1 mole, again, is this many atoms, which is that much mass, then my scale should read something much less. It should read half a mole, which is 6 grams. This is what the scale should read, because 6 grams is going to be 3.01 times 10 to the 23rd atoms, half of this amount, right? Because 0.5 is half of 1. So let's try this out. Let's have you try this out. Same idea here. I want you to take a look at, you have about 1 mole of each element in this case, right? In this picture. I want you to tell me how many atoms would be in this sample if it was 1 mole. How much atoms would be in this sample if it was 1 mole? Now, once you tell me how many atoms there would be, tell me how much mass it would have. And then now here I want you to vary that, the question now. The question is changing because now same idea. I want you to tell me how many atoms you got. But now I'm giving you half a mole. How many atoms would you have in lithium if it was half a mole, and how much would it weigh? If it was sodium, if you had half a mole, how many atoms would you have and how much would it weigh? And then do the same thing with 2 moles. If you have a hard time with these questions, hit me up a tutorial.